move on to the next question. Clear all this first. Okay, clear all this. We go to the next question. Okay, you read this question and see.
What angle must be exceeded so that the block will begin sliding? Hint, equate the expression for the static friction force to the maximum possible static friction force.
Okay, right. Now the question is different. Instead of increasing the mass of the object to find out whether it will slide down the inclined plane or not,
Mhm.
now I don't increase the mass of the object. The mass of the object remains the same. What I'm doing is I will tilt this inclined plane. At first it is 30 degrees. I will tilt this inclined plane, tilt it a bit more, tilt it a bit more, until a certain angle, the object will definitely slide down the inclined plane.
Okay.
From our experience, if we tilt the inclined plane a little bit, it won't slide down, right? And you tilt it until very steep, then
Mm.
the object will slide down the inclined plane. So the question now is, what what is the angle? What is the angle when the object will slide down the inclined plane? Okay, not? So the question is, when will the object slide down the inclined plane? At what angle will the object slide down the inclined plane? Okay, right. So now we look at
Mm.
the two opposing forces. Okay, the two opposing forces again.
Yeah.
One is the frictional force that is upward,
Mm.
that is supporting the object. So it is mu mg cos theta. My the label cannot type theta, so I put something like a zero there. But we know that this one is theta lah. So it is mu mg cos theta. So this is the component of the frictional force.
Okay.
So the component of the weight we know is mg sine theta. Mg
Yep.
sine theta. So these two components, they oppose one another. I would like to know when will this component, or
Mm.
rather this component mg sine theta, bigger than the frictional force. Again, I would like to know when this component of the weight mg sine theta will be bigger than the frictional force, which is mu mg cos theta. So I try to create an inequality. I say this component of the weight bigger than the static friction. So I copy down over here. The component of the weight mg sine theta, when will it be greater than the maximum frictional force? So mg sine theta, when will it be bigger than mu n? Mu n. And I change this to 0.65. I change the mu to 0.65. And the n, I change it to mg cos theta. Mg cos theta. I bring over this mg cos theta to the other side. So it will be mg sine theta divided by mg cos theta. The mg and the mg, they will cancel one another. They will cancel one another. As
Okay.
a result, sine theta over cos theta is greater than 0.65. What is this sine theta over cos theta? The sine theta over cos theta is actually tangent theta. This is from our knowledge of trigonometry. Sine
Okay.
theta over cos theta is tangent theta. So tangent theta is greater than 0.65. Okay. You look at the initial condition. The initial condition is what will it be when the component of the force is bigger than the frictional force? And the answer now is the angle must be bigger than this. So how to find this angle? You turn on your calculator, then you type shift tangent 0.65. See whether you get this answer or not. You turn on your calculator, shift tangent 0.65.
The degree, yeah,
What's the answer?
33.02.
33.02. Is it 33.02?
Yes,
So
sir.
we round off to three significant figure. The answer will be here, 33.0. If you round off to three significant figure. This one is four figure. So this is three significant figure. So over here, you can either refer to the table similar to the one that I have created here, right? The
Okay.
one that I've created here. So it's something like this. So the angle, let's say if it's 1 degree, 2 degrees, 3 degrees, 37 degrees until 73 degrees. So as the angle increases from 1 degree until 37 degrees, I try to calculate the maximum frictional static friction and also the component of the weight. So if you look at the maximum frictional force, when the angle is 1 degree, the maximum frictional force is 25.48 Newton. The
Yeah.
component of the weight that is mg sine theta that is forcing the object to slide down the plane is only 0.68 Newton. So this definitely cannot exceed the frictional force, the maximum frictional force. So you will not slide 1 degree, you will not slide down the inclined plane.
Okay.
Now, why I put the radian here? Because the Excel worksheet, they cannot accept angle in degrees. They only accept the angle in radian. So the Excel worksheet, I have to convert degree to radian. Then from radian, I substitute inside this formula here, right? Okay, never mind. So as we increase the angle 2 degrees, 3 degrees until 30 degrees, 30 degrees, the like just now lah, like what we did just now, 30 degrees, the maximum static friction is 22. The component of the weight is 19. So this weight is still less than the maximum frictional
Yeah.
force.
Okay.
So it will not slide down the plane. So I increase to 31, 32. 32 degrees, the frictional force is 21.61. The component of the weight is 20.77. Still less than the maximum friction. Will not slide down the inclined plane. So 33 degrees. 33 degrees, the frictional force 21.37. The component of the weight 21.35.
37.
Oh,
Okay.
so actually 33 degrees, it will not slide down the inclined plane, right? When it comes to 34 degrees, calculate the frictional force is 21.12, but the component of the weight is 21.92. So the weight exceeds the frictional force. So 34 degrees, you will slide down the inclined plane. So and so on. As we increase the angle, we see all red color. So all these other angles that become bigger and bigger, it will slide down the inclined plane. So coming back to this diagram here, I have created a moving, can move on. This angle can move. So as we move the angle, I calculate the angle here, and the component of the weight and the maximum frictional force. Where it's a negative number, then that means the weight has exceeded the frictional force. If it is a positive number, then the weight is less than the frictional force, right?
Okay.
So with increase, no negative number yet. We look at here, no negative number yet until zero, negative, right? So it begin to become negative. As I increase the angle, become more and more negative. So it will actually show you at which angle the thing will slide down the inclined plane. Now this is negative, it will slide down the inclined plane. So probably I move the angle, make it 34, cannot. This shows the angle here, the angle is here, 33.29, still slide down the inclined plane. 32, yeah, it will not slide down the inclined plane. So we can solve this problem by using calculation, or we can actually plot the numbers, substitute the formula, the numbers inside the formula, and actually find out whether which one is bigger, which component is bigger. Any questions so far?
No question, sir.
Can follow or not?
Yes, can follow.
Cannot hear. Okay, right. So we move on to the next one.